consider one of the special rules which I use for differentiating certain standard types of functions. These rules are the sum and difference rule, product rule, quotient rule, higher derivative, composite rule. We have chain rule for derivative of function of a function, and we have derivative of implicit function, and so on and so forth. But for the purpose of this class, we're going to consider the differentiation of the sum or difference of function. Or let's consider this illustration. If y equals to u plus v, where u and v are both differentiable function of x, then x is increased by x plus dx, then u and v will increase by u plus du and v plus dv respectively. Thus, y will increase by y plus dy. So this can be expressed mathematically as dy dx equals to dv dx plus du dx. This is what we call the sum rule. This is the sum rule. I want you to note from here that the limit of a sum is the sum of the units. I repeat myself. The limit of a sum is the sum of the units. So let's also consider for difference of two functions. That is, if you have something like this, y equals to u minus v. So the y dx equals to the u dx minus the v dx. So this is equation 2. This is called difference rule. It is called difference rule. So let's consider 2 to 3 examples to illustrate this. Examples. Find the differential coefficient of the following functions. So let's look at question 1, solution. Question 1, y equals to x to the power 5 minus 4x cubed plus 6x minus 3. So we're going to use rule 1 from our previous lesson, lesson 3 of this introductory calculus, where we're going to multiply through by d over dx. So it will now be d over dx of y equals to d over dx of x to the power 5 minus 4x cubed plus 6x minus 3. So from here, we're going to use d over dx to multiply everything inside the bracket. So the y over dx equals to d over dx of x to the power 5 minus d over dx of 4x to the power 3 plus d over dx of 6x minus d over dx of 3. So from here, we're going to bring out our constant out. Therefore, dy over dx equals to d over dx of x to the power 5 minus, this 4 will come out. That will be 4 d over dx of x to the power 3 plus, we're going to bring out this 6 to the back of d over dx. 6d over dx of x minus d over dx of 3. So from here, we can now differentiate each entity. So dy over dx equals to, from the first rule, so it's going to be 5x raised to the power 4 minus 3 times 4, 12x raised to the power 2 plus, this one is 6 power 1, 1 times 6 is 6, 1 minus 1 is 0, 2 raised to the power 0 is 1, minus, if we differentiate a constant from our previous class, the relation of a constant is going to surely give us 0. So 0. Let's tidy up this. It will now be, therefore, dy dx equals to 5x power 4 minus 12x squared plus 6. So this is our final answer. I believe you understand. So let's solve the second one. So question 2, y equals to x is power 5 plus 4x is power 3 minus 5x plus 4. We're still going to do the same thing. We multiply both sides by d over dx. So it's going to be d over dx of y to be equals to d over dx of x is power 5 plus 4x3 minus 5x plus 4. So let's multiply through by d over dx. So dy over dx equals to d over dx of x power 5 plus d over dx of 4x cubed minus d over dx of 5x plus d over dx of 4. So let's bring out our constant like example 1, like the way we carry it out in example 1. So dy over dx equals to d over dx of x is power 5 plus 4 d over dx of x is power 3 minus 5 d over dx of x plus d over dx of 4. So let's start to differentiate. Our dy over dx equals to, this one is 5x is power 4 from lesson 3. We have plus 3 times 4 is 12x is power 2 minus 5 plus 0. Definition of the constant will surely give us 0. So let's tidy up this. So therefore, our dy dx equals to 5x is power 4 plus 12x squared minus 5. That is our final answer. So lastly, let's consider example 3. Consider the third example. Y equals to 6x cubed minus cos x plus 5 sine x minus 2 exponential x. So what I need to do, we multiply it by d over dx. So d over dx of y equals to d over dx of 6x cubed minus cos x plus 5 sine x minus 2 exponential x. So let's open up this bracket. So it's going to be dy dx equals to d dx of 6x cubed minus d dx of cos x plus d dx of 5 sine x minus d dx of 2 exponential x. So from here, let's bring us our constants. So it will now be dy dx equals to 6d dx of x cubed minus d dx of cos x plus 5d dx of sine x minus 2d dx of exponential x. So let's start to differentiate. Okay, so dy dx equals to 6 times 3 is 18. 18 x is power 2 minus, from lesson 3, if you differentiate cos x, it's going to give you minus sine x. So it will be minus sine x plus 5. If you differentiate sine x, it's going to give cos x minus, and if you differentiate any exponential respect, it still give us exponential x, so is per x. So dy dx, so therefore let's tidy up this. It's going to be equal to 18x squared minus times minus will give us plus. plus sine x plus 5 cos x minus 2 exponential x. This is our final answer. I hope you
Feel
understand.
the magic in the air. Feel the magic in the air.
Feel the magic in the air. Magic System, Adewale, Shaoki.